we have minus 30 minutes of time left. Okay, so let's start with the first one, first presentation. Just one moment, I look at what should be actually keynote 2. And keynote 2, I would welcome Professor Muhammad Mustafir Rahman from Wichita State University, US.
Well, thank you for the nice introduction. You need to give me the ability to share my screen, I think.
Yes, I think you should have that right to do it.
Okay,
and
okay, I think I can see that.
We will mute
okay.
our mics and hide behind the wall, and all yours. You have half an hour.
Okay. Great. Does everyone see my screen all right? Just to check.
Yes,
sure.
Yes, it's okay. It's okay.
Okay. All right. All right. So I'd like to first of all acknowledge that this presentation I'm making, I teamed up with my graduate student, as we all do as a faculty member. My graduate student is Mohammed Hassan Habib, and he gathered the information, put together a lot of information for me to make this presentation as a possibility. So he's working on his PhD dissertation with me at the Wichita State University. So I'd like to thank him for all the hard work which went for this. Actually, we are in the phase 3, so I don't have the go backward, maybe some. Yeah, that heading. So the title of my presentation is the phase change materials for application in building thermal energy storage. So we are talking, this is not a real completely new topic. We had been using phase change material for thermal energy storage for a while, but we try to look into what has been done and what is coming forward. So that was the idea of our work, to gather information and to set up some sort of pathway for the future. So that is the idea of this particular work. You have my email address here. So as we ran into the lack of time for question in the plenary session, so feel free to send me with your questions in my email after we finish the presentation. I'll be very happy to chat with you and go over more details of anything which I don't make clear in this presentation, or some more details of what you are interested to know about it. So just to get a kind of structure in the presentation. So I'm going to talk a little bit about motivation, as there's been a lot of talks going on with the global warming and the climate change. So all of us are quite familiar with that. And then briefly talk about the different thermal energy storage methods, then talk about the phase change material properties, what are the real properties we look for when it choose a phase change material, and then classification of the phase change materials and the phase change material application in the thermal energy storage systems in varieties of building application. And then we're going to spend some time looking into the limitation which we come across as in the nature engineers. So we try to build things, and then we know that the nature always puts some limitation on us, and then we work towards getting around those limitations. And then finally, I'm going to briefly talk about, because we have elaborated that more in our paper, which will be published as a part of the proceeding, just briefly introduce you with the case study to show that, yes, we do save energy using the phase change materials. As we are, world population is increasing, we all know that, and then we are always striving for the higher quality of life. So both of these combined is creating a big demand for energy. So the energy demand is increasing as we produce energy. Of course, we use all different kind of sources which we have. Then we naturally raise the level of greenhouse gases, which is harmful to our climate. And now we need to look for alternative sources of energy or the use of energy in an efficient way so that we can solve that climate change problem. Just looking at some numbers, the building sector accounts for about 76% of electricity use and 40% of all US consumption and associated greenhouse gas emission. So it's a reasonably big sector, energy which where energy is consumed. And if you look at some of the breakdown of that, we see that this consumption is mainly associated with the heating and cooling of the indoor environment to obtain the user's best comfort, thermal comfort level, which we try to give to the users as is. Looking at some more things, phase change material provide an elegant, realistic solution to increase the energy storage efficiency, and the renewable energy can be used if we can associate that with the energy storage. The application of phase change material in thermal energy storage system reduces the mismatch between the demand and supply, improves the performance, the reliability of electricity distribution network, and plays a vital role in conserving energy. So this goes more than the building sector. It is also the power sector, which actually that was I did more work on the power sector before. And if someone had a question on that, we can work on that. Implementing phase change materials and storage in general, we can see there's two routes. One is the thermal route and one is the chemical route. And we have worked on actually both of the routes, and I have actually review paper on the chemical route as well. But today we're going to talk about primarily thermal things. So thermal route, we store energy by sensible heating as well as by latent heating. And sensible heating, if you look at the latent heating first, we can conceptually have solid liquid phase change, liquid gas phase change, and solid phase change. But in building applications, of course, the solid liquid is the only feasible one. So this is the only one which really is possible in the building applications. And then these, even for the power application, because of the gas pick up a lot of volume and become a difficult system to design and so on. And in the sensible heating, of course, as the temperature increases, it will store energy, and it will happen both in the solid phase as with the liquid phase. So practically what we see that we're going to, you can build a good phase change energy storage system by using the solid liquid conversion and then having some storage in the sensible mode, both in the liquid as well as in the solid portion. So if we look at the equation, how much energy we're going to store, we can do a very simple equation like this, that we're going to store from initial temperature to melting temperature, and then we're going to store isothermally primarily, or approximately isothermally when the material changes the phase from solid to liquid, and then we're going to store more as you go from the melting temperature to the final temperature. So this is for the charging phase of the system, and of course the discharging will be just the reverse of that. Okay, so looking at the desirable properties of the phase change material, there'll be thermal properties which are important. The melting temperature in the functioning range, like where we want to maintain the temperature, and of course we like to have a high latent heat of, and then the specific heat also add up because we'll have some sensible heating in both phases. So if the higher specific is better for us. And the high thermal conductivity is extremely important because that is going to determine the rate of heat transfer during the charging and discharging of energy from our energy storage module or energy storage in some of the physical properties are also important. A small volume change on phase transformation, favorable phase equilibrium, congruent melting of the phase change material, and the density should be high so that we can build a system with a reasonable amount of mass. There is no a few kinetic properties. There is no supercooling, adequate rate of crystallization, and the nucleation rate is high. So those are the desirable properties, kinetic properties. A whole bunch of chemical properties is needed. PCM is entirely reversible freezing melting cycle, long-term chemical stability, compatible with the conception material, and non-toxic, non-flammable, and non-explosive to provide safety of the system. The phase change metal should also be readily available in large quantities and at a low cost. And all these different things, ideal things, does not hold in real life. So always very striving to make the system work by doing the fine tuning. And one of the fine tuning we do is using the nanomaterials along with the phase change material to change the properties. And we have done work with both solid liquid melting as well as in the high temperature system. We use the radiation, enhance the radiation using the nanomaterials. So, but that of course increases the cost of the system. So if we look at the phase change material, we can see that a good number of materials we use, particularly for low temperature application, are organic group. A lot of paraffin compounds has been used, and then some non-paraffin compounds have been used. So this is the organic group, and then of course the inorganic group we have the salt hydrate as well as metallic. Both are very popular, and we can make eutectic by combining organic, inorganic, organic, and inorganic. So if we look at the some of the advantages and challenges we face in each of these groups, in the organic group we see that they're available as in an extensive temperature range. Latent heat diffusion is fairly high, no supercooling, usually chemical and thermally stable, and they are also recyclable, which is very important also in the life cycle design. Good compatibility to other materials, usually non-reactive and safe, so that we get a lot of advantages by using the organic compounds. But it has some challenges, particularly the low thermal conductivity, relatively large volume chain, low phase change enthalpy, and some of them happen to be flammable. In the inorganic group, we see a high heat diffusion, high thermal conductivity, which is a very desirable property, low volume chain, short phase chain, usually inexpensive and non-flammable. But we do suffer from some of the properties which you don't want, like supercooling, corrosion, segregation, reduction in efficiency, separating use. By making eutectics, we can get a wide range of phase change temperatures. The most important things or most usual application of eutectics. It do provide high heat capacity, little supercooling, good chemical and thermal stability, but it has the low thermal conductivity is the problem. Now let's talk about some of the traditional application of phase change material in the building sector. One of the things which people has used for a fairly long time is the solar water heating. Solar water heating is a very, very simple system we can build, essentially by acquiring the energy from the sun and storing it. So typical designs will be using a built-in storage tank containing a layer of capsules containing phase change material at the bottom of the tank or on the side of the tank. So that is going to store the energy which we gather from the sun. Another sector is space heating and cooling. Phase change material can be applied to both active and passive heating and cooling system. In the passive system, we typically encapsulate the material into the building structure such as ceiling, floor, concrete, gypsum, wallboard. In the active system, we capture the energy from the sun and then try to use some of the energy for the generation of electricity if we can gather enough from the sun. The waste heat recovery is another application. It's a very simple application, but typically these are not in the residential application, these are not great amount of heat. It's in the industrial possibly have a lot of heat. But that's another application which we can think of. Then let's talk about the limitation of phase change material. One of the limitations we come across is supercooling. Supercooling happens that the liquid solidifies below its usual freezing point and thus experiences a delay in starting the solidification process. So we store the energy, but we have a difficulty in extracting the energy back from the system. The group which suffer more on this issue is the salt hydrates, and the supercool before freezing point during the extraction of the stored energy after prolonged use. This causes a decrease in the performance of the phase change material and will eventually lead to slower heat recovery from the phase change material. It is more common in inorganic phase change materials, I've talked about already, to suffer from this limitation. And then also what we see that when you do the encapsulation, we have the nucleation, we have the lack of nucleation space for the small space. So that's another issue we need to solve. The low thermal conductivity is a major problem, but at the same time, there's been a lot of work done on this particular to address this particular problem. Phase change material possesses a very low thermal conductivity generally, which results in lower heat transfer rate in and out of the latent thermal energy storage application. We have the residential sector, essentially low thermal conductivity, could severely affect the performance factor with the phase change material system. But the lengthier with the lower thermal conductivity, the occupant comfort level provided by the phase change material is not realized with full capacity. The phase segregation is another issue in using the phase change material. Is one of the most significant adverse influences on cyclic thermal stability of the phase change material. It is most usual in multi-component phase change materials where density of components is dissimilar, guiding to the eventual separation of the component due to gravity, which will change the melting point of the phase change material. Incongruent melting, when a solid substance does not melt uniformly, particularly the salt hydrate-based phase change material, is another main cause of the phase segregation in the phase change material system. Phase segregation restricts the long-term stability of the PCM. So we like to avoid that as best as we can. In residential application, fire safety is extremely important. And what we see that some of the very common building material like gypsum, plasterboard, has been used quite heavily in the residential sector. It tend to be quite safe. But when we use 24% paraffin-based phase change material, the fire hazard increases tremendously. So we have to be careful in applying the phase change material and make sure that the fire hazard does not happen. The corrosion is another thing which you have to be careful in, essentially in any engineering design. Compatibility is the most important factor. If the PCM material is not compatible with the container, it will result in corrosion of the container and some changes in the PCM properties. The ultimate result of the poor performance of the heat storage system, including the leaking. So we need to be mindful of that. And the cost is again is the ultimate thing we have to look at. If we particularly if we change the phase change, we want to change the phase change properties and use the nanomaterials, that we have to be careful about that. The cost does not increase tremendously. The another interesting thing which we found that the general public is not that much aware of the phase change material, and then we need to, as engineers, need to be talking to the public and highlighting the benefits of the phase change material to make it more acceptable to the technical as well as non-technical. We looked into a case study to see how much energy saving we can do. And we did this is a fairly straightforward exercise, I would say. We use the we compared the energy use without the PCM as well as using the two PCMs, how much energy we can save. And the software we use, the Energy Plus software, which is available from the Department of Energy for public applications. It has been quite, it's a very simple software, but it has been quite well validated and verified by different authors, particularly with the ASHE standard 140, which was the important validation exercise has been done. So we use this software, and then we looked into a heating need of a building, heating and cooling of a building in each of the campuses. And then in the cool heating season is essentially starting from next month to December to February. And what we saw that the heating requirement kind of decreased. And then these are the numbers I'm going to show you in the next slide as well. So this is the kind of, in the cooling load, we did it without the PCM and then looked at what happened at the PCM, and then compared that for the whole year. So maybe we can just look at from this table. Without PCM, that much is the kilowatt hour requirement for the building which we use. With the by PCM, we got it lower to by 2.13%. With the DuPont, we lowered it by 4.34%. The cooling load, 15049 kilowatt hour, we got 3.74% saving with the PCM, 2.02% saving with the DuPont. And then overall for the whole year, if we do that, this is the load and this is the, so we get right around 3% saving using the PCM. So if we do use PCM, then we do get some savings. It was as long as we can justify the cost of using the PCM, it should be. So the use of PCM to reduce the consumption of residential building has been discussed. The two distinct PCM with the melting point 21.6 degree and 29 degree were investigated in the study. The study was conducted using dynamic simulation software of a DOE mid-rise apartment building, energy performance, as well as the weather, using the weather data of the cancers with and without the use of PCM material. Can be deduced from the numerical analysis finding that the application PCM external walls and roofs and store heat energy from solar radiation, hence reducing the energy consumption for heating and cooling space. The industry resulted in the maximum decrease of 4.34% in the heating energy requirements, reduction of 3.7% for cooling requirements, and maximum reduction of 3.2% overall throughout the year. So I'm leaving 5 minutes for questions so that we can have a good discussion of this by getting input from the audience.
Thank you, Professor Muhammad, for the great presentation. Any questions from the audience, please? Okay, I think we are okay because people are probably still having their coffee right now. We miss coffee break and I have my coffee right now. Thank you for the great presentation. They have your contact details, and anyone who want to ask some question will be able to email you. Okay, thanks for the presentation and for being present in the conference. So we go to the next, and the good timing actually, we got 5 minutes. I have to make another for 25 minutes before the end. Thanks a lot. Let me see.
Thank you. Thank you.
Thanks. Now, next presentation is submission 22, the effects of slow and fast pyrolysis of the yields on the yields of properties of production bio oils from macadamia and nutshell. Energy is becoming very important worldwide. So we are looking for a presentation which will be given by Mr. Mehdi Hassan from Central Christian University, Australia. Hassan, welcome, all yours now. You have your 15 minutes.
Sharing my slides.
All good, we can see your screen.
Okay. Hello, everyone. I am Mohammed Mehdi Hassan from Central Queensland University. Today, my presentation topic is the effects of slow and fast pyrolysis on the yields and properties of produced biooils from macadamia nutshell. So the presentation will start with a brief introduction on the research background and problem statement, which will lead to the description of the objectives of this study. After that, the methodology of the present study will be discussed with the help of the schematic diagram of the experimental setup, and then results will be discussed in detail. Finally, I will conclude my presentation with the concluding remarks. As we know that the energy demand around the world is increasing at a faster rate. However, the conventional process of producing energy is not good for the environment. It is detrimental for the environment, and the reserve for fossil fuel is decreasing at a faster rate. So we need to find out renewable energy sources. Renewable energy sources should be utilized to produce energy and to mitigate the problem of environmental degradation. In this regard, macadamia nutshell can be a potential renewable energy source if it can be combined with emerging technology like pyrolysis. So macadamia nutshell is usually generated when the macadamia nuts are processed in industries. And after the processing of macadamia nuts, the shells are usually thrown out, which is detrimental to the environment. So if it can be combined with pyrolysis technology, it can be useful, and it will save the environment from danger. Macadamia nutshell has a lot of potential to use in pyrolysis process, like it has higher content of volatile matter, which is above 70%, and lower ash content. So these are the promising aspects of macadamia nutshell to use in pyrolysis process. However, there are several parameters which affect the pyrolysis process. Among them, heating rate is one of the important parameters which plays an important role to determine the quantity and quality of the energy products obtained from pyrolysis process. Therefore, this study aims to assess the potential of converting macadamia nutshell to energy product, especially a bio oil using pyrolysis process, and to evaluate the effect of heating rate, the slower heating rate and faster heating rate on the quality and quantity of the produced bio oil from macadamia nutshell, and finally to determine the suitability of the produced bio oil for an engine fuel using pyrolysis process. So here you can see that these are the macadamia nuts covered with shells. So after processing these macadamia nuts in the industry, these shells are generated. So we collected the shell, and then it was sun dried for 12 days. And after that, desired size was prepared with the help of a shredder, which is 2 millimeter size. And then these shredded shells is fed into the reactor, auger reactor. In case of fast pyrolysis, this reactor has both facility of conducting both slow and fast pyrolysis. In case of fast pyrolysis, the macadamia nutshell is fed into this hopper, and then nitrogen gas is parched to make the system inert. And after that, from control panel, the temperature heating is started, and the temperature is set. So when the temperature reached to the desired temperature, which is 500 degrees Celsius for this study, auger motor is started, which carry the macadamia nut shell through this auger. And during this travel, the pyrolysis process takes place. After completing the travel, the macadamia nut shell is converted into biochar and is dropped in this biochar vessel. And it also produces gas after during pyrolysis process, which is a condensable and non-condensable component present in that gas. So this gas is passed through this condenser, and condenser condenses the non-condensable gases into bio-oil, and non-condensable gases, which is called syngas, syngas is left the system through this exit valve. In case of slower pyrolysis, this whole auger part is switched off, and the material is fed into this inlet. And this vessel is acted as a reactor vessel. So the material is fed, and the nitrogen gas is passed, and then the heating is started. So at a rate of 5 degrees Celsius per minute, this is the slower heating rate. So slowly the reactor heats the feedstock, and when it reaches to the minimum temperature for the pyrolysis process to take place, the pyrolysis process starts, and it converts into biochar and gas, and the gas is passed through this condenser. And the rest of the process are similar like fast pyrolysis. So after this process, the bio oil and biochar and syngas is collected. So from the characterization result of macadamia nut shell, we can see that the volatile matter is very high, which is good for pyrolysis process. It indicates that the macadamia nut shell is good for pyrolysis process, and the carbon percentage is also very high. These results indicate that the macadamia nut shell is a suitable feedstock to use the pyrolysis and to produce energy products from macadamia nut shell. So from the experimental results, the yield of different energy products, you can see that if we compare slow and fast pyrolysis, the bio oil percentage, which is nearly 50%, is higher compared to the bio oil obtained in slow pyrolysis. The reason is that in fast pyrolysis, the feedstock is exposed in the reactor when the desired set temperature is achieved. So the heating rate is very high, and the feedstock does not get enough time to further break into non-condensable compound. So, that's why the bio-oil percentage is higher in fast pyrolysis. In contrast, the biochar percentage is higher in slow pyrolysis compared to fast pyrolysis. The reason is that the feedstock is slowly heated in case of slow pyrolysis process. So it prevents the slower heating rate, prevents the biochar, prevents the feedstock to convert into condensable and non-condensable compound. Rather, it breaks into more stable structure, which is biochar. So that's why the biochar percentage is very high in slow pyrolysis process compared to fast pyrolysis process. And these are the chemical compounds present in the bio oil, which was obtained from the analysis of gas chromatography and mass spectrometry. So these are the major chemical compounds. So as we can see that the benzene has the highest peak area percentage, which is a good indication for the bio oil to produce liquid hydrocarbon, because benzene is an important compound in the production of gasoline. So this bio oil has potential to produce liquid hydrocarbons. And the second highest area percentage is you see the phenol compound. Phenol compound is the presence of phenol compound indicates that these phenol compounds will help to increase the preservation stability of the bio oil. And when it is kept to the outside environment, it will prevent the bio oil to be oxidized. But however, the bio oil has some acidic compound, which is not good for the bio oil to use it as engine fuel, because acidity it will create the aging problems of the bio oil. So it will limit its application as an engine fuel. So this the suitability of the bio oil to use an engine fuel or the commercial fuel, it can be clearly understood from the physiochemical properties of the bio oil. So we can see that the calorific value, if we compare it, it has been compared with the biodiesel ASTM standard. So from that, it is clearly seen that the range of calorific value is not close to the biodiesel standard. So this is not suitable for engine application, and kinematic viscosity, water content is very high. So from these results, we can say that if we want to use it as engine fuel, it needs proper upgradation using a various upgradation process. So from this, we can make the conclusion that the bio oil, the macadamia nut shell has a lower moisture content and a higher carbon percentage, which makes it a suitable feedstock for pyrolysis process. And the higher amount of bio oil was obtained, which is around 49.7% in first pyrolysis. And in the bio oil, there are major chemical compounds present like benzene, toluene, phenol, styrene, and acetic acid. However, due to the higher viscosity and water content, bio oil's application as engine fuel is not possible at this stage. Proper upgradation is required. These are the references of the information we have extracted. So that's all on my side. Thank you for your attention. If you have any question, please.
Thank you for the great presentation. We have time for one or two short questions. So any question from the audience, please?
Can I have one question, please?
Yes.
Sure. Thank you. Thank you, Mehdi. That's a great presentation. So there are different methods to convert the biomass into biofuel or electricity, and there's people also utilize biomass to convert to fertilizer. So like composting. So have you compared the carbon footprint of the method that you are using, pyrolysis, and other method, and also composting?
The scope of the present study, actually, we analyzed only the bio oil part, the liquid part only. But in our other study, we also will also analyze the biochar. And as you mentioned that to compare it with the other process,
Yes.
we have also planned, but we haven't done it yet.
Yep.
In the future, we will compare the biochar from pyrolysis and biochar, the solid part from other processes.
Yep. Thank you. But what I mean is, not the efficiency. What I mean is the carbon footprint. That's what people are, worried
Yes,
about.
that should be some other study. It's very serious, a very good question, actually. And we don't have too much time. I have only one small question. Why did you select macadamia? That's the most expensive oil that you produce, actually.
Actually, where I stay now, there are lots of macadamia plants. So they are just...
Yeah, that's it's not a joke, actually. Question is, will you be able to do the same with sunflower shells or canola shells actually, which are Australian made, I would say. Will you consider using other sources?
Yeah,
of this
we are also planning to use other shells as well.
Okay, thanks a lot. We don't have time for more questions. We will go to next presentation. I hope we all enjoyed. There are more questions. We will email you more questions later.
Thank you very much.
Okay, thanks a lot. Now, the next presenter is not present, but presentation is here. So I will run presentation and share my screen. Let me see how this goes.
Also, please select the, share with the sound.
Screen. Okay, just 1 second. This is the one. Share. Okay. Just 1 second. Let's see. Where am I now? Okay, I just have to find try again to share the screen and find the sound. Just 1 moment again. Screen sharing. This is the one. Share screen. Can anybody hear the talk?
No.
No, just let me find where is that screen sharing option.
Bobin, please, can you help him?
Yes, Dr. Milan. I'll play the video for you, Doctor.
Yeah, because I cannot find that audio option.
Yeah,
No
don't
worries.
worry. Dr. Bobin will help with it.
Okay. Oh, okay, I found it. That's fine. That's fine. We can do it. Just 1 second. It should be okay now.
I will talk about design and application of the rotary Limousine compressor.
Yes, we can hear.
All good.
In this topic, we'll touch base on the Limousine curve, the Limousine technology, and how such a technology is applied to fluid processing machines. The work in this talk have been done over years, and there's still work in the pipeline with the lead by Associate Professor Dr. Ibrahim Sultan. Currently, we have a few PhD and master students working on different aspects and different phases of the Limousine technology development. I would like to take this opportunity to thank Christopher, Koi, and Ibrahim for their contribution to this presentation. As you know, machines are categorized into 2 main types, namely rotary and reciprocating machines. The Limousine machine is of the rotary machine family. It is important to note that the Limousine machines are of positive displacement type. These machines take small chunks or packages of working fluid at a time into their working chamber and process. The process can be adding energy to the working fluid in the case of compressors and pumps, or extracting energy from the working fluid in the case of expanders. This is the distinct difference between positive displacement machines and turbo machines. In turbo machines, the flow of working fluid is continuous instead of package-wise. The main advantage of positive displacement machine compared to the turbo machine is the capability of processing multi-phase fluids, which exist in both liquids and gas forms at the same time. This multi-phase fluids can easily damage the plates and impellers of turbo machines due to the impact between high-speed fluid droplets and the plate's surfaces. Here I would like to go through the curves that I use to manufacture the profile of the Limousine machine, rotor, and housing. These curves are also the base of the Limousine motion. So the machine rotor and housing are manufactured to the Limousine curve, and the equation of these curves are I is equal to B plus A sine theta or cosine theta. Um, the cosine function will take the x-axis as a mirror line, while the sine function will take the y-axis as a mirror line. As you know, these curves are in the polar coordinate. To apply for fluid processing, the coefficient B and A of this equation over here are to be carefully selected to prevent dimples and double loop. As you can see in the figures here, the top figure, the outside curve is single loop, while the red one here, as you can see at this point at the pole, you can see that is the dimple. If we move to the second figure, the red curve here, you can see we have double loop. So for Limousine machine applications, we want to use the black curve, the black dotted curve on the first figure here. So this curve will provide dimple free and single loop. The reason behind the use of single loop and dimple free curve is that these curves ensure a smooth motion and transition of the machine rotor inside the housing. On the next slide, we'll see the animation of the motion of the rotor inside the housing. Here, as you can see, the red dashed line represents the housing profile. So which is this one? That's a housing profile. The red solid line rotating there represent the rotor, and the blue line on the outside is a circular curve. I plotted here for comparison purpose. So this is a Limousine motion. As you can see, the straight line, this one we call the rotor cord, and that rotor cord rotate and slide about the pole O. This point is a pole O. So currently we have three Limousine machine embodiments. There are three of them. We have Limousine to Limousine machine, we have circle Limousine machine, and Limousine to circular machine. The distinct differences between these designs or these embodiments are the rotor and housing profiles. So if we go from left to right, as you can see, the left one, we have Limousine to Limousine machines, where you have the housing of the machine is of Limousine curve, and the rotor, half of the rotor is a Limousine curve, and that curve is mirror about the rotor cord. Okay, and it creates a lenticular shape for the rotor. Move along. The next one is a circular machine. With this machine, we have the housing and the rotor are both made of circular curves. However, the motion of the rotor inside the housing follow the Limousine curves. The downside of this is the gap between the rotor apex and the housing changes as the rotor rotates inside the housing. This will create trouble for sealing, because the seal will have to travel a large distance to cover that gap. So to address that issue, there's a third embodiment we call Limousine to circular machine. So as you can see, the housing of this machine is Limousine curve, while the rotor is comprised of two circular sections, and then they are mirror image of each other about the rotor cord. So this type of embodiment will have the advantages of both the design, where you have the Limousine curve, but then you have the advantage of manufacturing the rotor, because you just need to follow a circular curve here. It will be easier to manufacture. This Limousine to circular machine and the Limousine to Limousine machine, you don't have the problem where the gap between the rotor and the housing keep on changes. So it's constant throughout the rotation. On this slide, we'll talk about the work on Limousine machine. The work on different machine embodiment has been carried out over the years to investigate the use of both Limousine and circular curves for the rotor and housing profile, whilst maintaining the Limousine motion of the rotor inside the housing. The other work is the the rotor and the housing share the same rotor core. In fact, in the case of the Limousine to Limousine machine, the lower half the rotor profile is the same as the housing. Therefore, to prevent the rotor housing interference and at the same time minimize the rotor housing gap, an interference prevention scheme has been developed, and this is shown in the work by Sultan here. And having the design and interference in place, it is now important to optimize the geometry of the machine to suit the working conditions set out by particular applications. It's like machine inlet and outlet pressure, the type of working fluid, the machine working speed, and so on. On top of that, high volumetric and isentropic efficiency are to be maintained. And the optimization method, we can use SPSA or simultaneous perturbation stochastic optimization or Bayesian optimization. Their work on the inlet and outlet valve and the control of the valve for expander and compressor. With the case of the expander, the amount of fluid induced in the working chamber per working cycle is critical. Hence, the incorporation of the inlet valve only. For the compressor case, it is critical to control the outflow of the compressed fluid. This is the reason to include the valve at the machine outlet only. These valve design and control problems have been and currently being investigated, as shown in the literature below. The thermodynamic performance of the machine with and without the control valve have also been studied mathematically. Along with these, the importance of having apex and side seals and the dynamic performance of these seals based on the machine working condition of the machine have been modeled and studied. Port geometry and port position of the inlet and outlet ports have also been incorporated and investigated. Currently, CFD simulations have been carried out to verify the soundness of the mathematical model. These simulations and the mathematical models will help inform the prototyping and laboratory experiments stages down the track. That concludes this presentation, and thank you for your attention. If you have any question, please feel free to ask, and I'm happy to answer.
Okay, hi everyone. Because presenter is not here, I suggest.
Oh, I'm here.
Ah,
It's me.
just a second. Oh yeah. Sorry. You didn't want to.
No, it's okay. It's okay.
That's okay. Then we have questions for you. I mean, are there any questions?
Okay, I have one question.
Yep.
Okay, it is very interesting your work. I didn't do research in this field. Please share how to set up the experiment of your work for study about thermodynamic performance.
So yeah. Is that all of the question? Yeah.
How to set up the experiment? How to set up?
Yeah. I get it. Is it all? Is that all? Yeah.
For test.
So what we've been doing, we developed the mathematical model, and we have optimized the design, and we have run the CFD simulation. So the next stage will be we use the outcome of these mathematical design and CFD simulation, and we have the dimension. We'll create a prototype, and then we put it in a system to test. You see, so we have inlet and outlet, and we have sensor to measure the temperature, the pressure, and the torque, the speed of the crank, and we'll compare to the mathematical model and the CFD simulation to make sure that the design is sound and then achieve the higher performance. So that's the plan for the next phase.
Okay, thank
And
you.
due to
for the
COVID,
sharing.
we have started, but then due to COVID, we have to delay the project for the whole year.
Okay. Okay. It's
So
the
it will
same
happen
of
very
my
soon.
work. Okay, thank you for your sharing. Thank you.
Okay, thank you for the presentation and for the questions. So we can to go now to next presentation on the same topic, I guess. This is submission 62, geometry design of the Limacom positive displacement compressor using Bayesian optimization, Mr. Kui Lu.
Yeah, that's me. So, sorry, I just open my start my video. Yep.
Okay, you can take over.
Yeah. So I just play a pre-recorded presentation from my end.
You want to run it? Okay.
Yep. Thank you. Just give me a second. I'll just make it. Yeah. Yes. So can everyone see my sharing the screen?
Yeah, we see the picture. Let's see the sound, if sound is there.
Yep.
The same problem that I had. You have to go back, and before sharing the screen, you click on enable sound.
Okay. How about now?
No, we don't hear anything. Did you click on join with the sound before you started? Actually, before you started sharing.
Yes.
I think you have to stop sharing and share again. And before you share, there's an option to enable sound.
Yeah, before the sharing. Before the sharing, you have on the left-hand side says
yes.
Join with the sound.
Share the sound. Yes, I saw that. Yep. Okay, let's try it again.
Yeah.
Good
How
morning.
about now?
My name is Koi Lu.
All good. Good luck.
Australia.
Yep. Thank you.
And I really appreciate this opportunity to present at this conference to share a recent research which is conducted by Dr. Ibrahim Sultan, Dr. Trong Fong, and myself. What I'm going to share with you today is an application of the Bayesian optimization in the geometric design of a class of compressor, which is called the Limousine rotary compressor. Before we move to the optimization procedure, I would like to make a short introduction to the Limousine rotary compressor. The Limousine rotary compressor is featured by the profile of the rotor and housing are generated based on a mathematical curve, which is called the Limousine of Pascal. And during the operation, the rotor of compressor is made to rotate and slide about point O, and the midpoint M of the rotor cord stays kinematically on the base circle. This animation here shows the operation of a Limousine compressor, which the blue line is a perfect circle, and the red dashed line is the Limousine curve for the machine housing. With these geometric features, the Limousine compressor has a compact size, and the way of designing the rotor implies the double-acting nature of the machine. Additionally, the gap between the machine housing and the rotor apexes is constant at any angular displacement of the rotor, which means the vibration on the apex seal can be reduced considerably, and as such, a better sealing performance can be expected on this type of compressor. Also, the geometric parameters that control the machine performance are quite straightforward, which benefits the optimization procedure. And the most distinguished feature of the Limousine compressor is that with the same machine size, a larger volumetric capacity can be realized by only changing the Limassol aspect ratio, which is the beta in this equation here. The purpose of this study is to use the Bayesian optimization to optimize the geometric parameters of the Limassol compressor to meet some specific volumetric and geometric design requirements, which are reflected by these three parameters. The first one is the rotor housing clearance, which is the distance between a random point on the profile of the rotor to the machine housing, as indicated in this figure here. And the reason why we have this clearance is because, as mentioned previously, the profile of the rotor and housing are based on the the same Limassol curve, and it is unavoidably that interference issue between these two components occurs during the operation, which might significantly affect the machine performance. So to prevent that, the rotor housing clearance must be ensured to be big enough so that these two components will not interfere each other during the operation. And the next one is the volumetric ratio, which is defined as the ratio of the minimum chamber volume to the maximum chamber volume. Generally, with the clearance has been satisfied, the minimum volume, as indicated in this figure here, should be kept as small as practical so that the volumetric performance and the machine capacity would not be significantly affected. Hence, this ratio here is to indicate whether the machine, this Limassol compressor, can present a satisfactory volumetric performance or not. And the third one is the induced volume, which is the volume of the working fluid that flow into the chamber during the suction stroke. This induced volume is to measure the effect of this residual fluid on the fresh charge during the suction stroke. The purpose here is to make sure these three parameters, the rotor housing clearance, the volumetric ratio, and the induced volume, they are satisfied with some predefined design requirements. To do that, we apply the Bayesian optimization. The reason is that generally the optimization of compressors is usually regarded as a black box problem in which the mathematical expression to relate inputs and outputs it's quite complex and sometimes it's impractical to be obtained. So for this type of problem, Bayesian optimization method has been proven to be a very efficient and accurate, and it starts with sampling the data, starting data, to build a prior distribution by using the Gaussian process. And from this prior distribution, the Bayesian optimization developed a surrogate model to describe the optimization problem. And after that, some new data point will be sampled from the searching domain. And the Bayesian optimization employs the acquisition function to evaluate whether the candidate point is suitable for the next evaluation. And in our optimization procedure, the design variables are the half chord length L, the Limassol aspect ratio beta, and the rotor clearance LC. And the requirements, as we predefined, is shown here. The objective function of the optimization is like this. this is the flowchart to illustrate, this optimization procedure. As can be seen, we firstly generated 10 sets of the data and obtained the corresponding objective functions using the geometric model as I presented previously. And we then feed these data to the Gaussian process to build a surrogate model. And after that, we sample some new data points from the searching domain and use the acquisition function to determine the next point. And for this optimization, it is relatively impractical to find the exact set of the desired variables that can produce the global optimum. And also, it might exist multiple settings of the desired variables that yield the same result due to the nonlinear relationship. So for the terminating condition, it is more feasible if the global optimum is reflected by a number of results obtained from the optimization. As such, we decide that the terminating condition is when we obtain the 90 sides of the results from the optimization. And these histograms are the distribution of the desired variable and the objective. So as can be seen from here, the objective function concentrates in the low value region, and it indicates that the Bayesian optimization tends to produce the promising outcomes, as these are the low values here. And also from this optimization, the set of desired variables that produce the minimum objective function can be reviewed from here, which provides a very useful information to designers and manufacturers. So yeah, thank you. Thanks for attending my presentation. Thank you.
Okay. Thank you. Thank you for the presentation.
Thanks.
We have time for one question, maybe. That's okay. I see we already had a question on this topic. So we get to go to next presentation. Anybody who would like ask question, please email questions to authors. So next one is submission 127, investigation on smart green mobility, future smart green mobility case study in Saudi Arabia. I invite Mr. Abdulaziz Aldakel Allah from Aramat University to give us presentation. Just 1 second. I don't see Abdulaziz, and I'm sure he will be here because he's my student, and we have great work done with the industry. And we do conduct a survey in Saudi Arabia, and we do in Australia now. So I don't know why it's late. We go to next presentation. I'll call him over the mobile phone. He's coming. Okay. Abdulaziz, welcome. Abdulaziz, you can unmute your mic, and we are ready for your presentation.
Hey, hi, how are you?
Very good. Okay, all yours. Can you share your screen?
Yes, of course. Sorry if I've been late. I thought it's 11. I thought it's 11:15. So
that's okay. We even have keynotes missing the time. That's why we have another keynote after our presentations. So there is a problem with the timing. Anyway, all yours now. Just share the screen, please, and we are listening.
Sure. Hello, everyone. My name is Abdulaziz Al-Dakhirallah. Today, I'm going to talk about the development of an intelligent transport system and public opinion on the transition. My colleague Narjan, Tom, Justin, Boston, and Milan Simic. So before I start, I would like to introduce the two beautiful city of Melbourne in Australia, which I'm doing my PhD in mechanical and manufacturing engineering, as you can see in RMIT University on the right side. And there is some kangaroo in the campus that we are seeing. In the left hand, my hometown, Riyadh, the city in Saudi Arabia. Moving to the outline, today we're going to introduce the project objectives and the role of artificial intelligence, also the artificial intelligence in traffic system modeling, comprehensive system for traffic data collection, analysis, and data management, also public in the transport system, the role of social media in intelligent transport systems, and finally, the public opinion on autonomous vehicles. To move forward to the introduction, there is two main goals on this project to report the improved transport safety and efficiency, the development of new computer vision, algorithm, artificial intelligence applications, Internet of Things, cloud computing, and investigation and rising public awareness of the transition in the transport sector. This has come with the collaborative with the Macadamia from RMIT University, the School of Engineering, as well as the industry in real-time traffic. And the right picture here showing the traffic in Tullamarine Road, which is, it should be more crowded and traffic, but with the COVID time that we took this picture. Project objectives and the role of artificial intelligence. So the following specific objects are expected to enable fulfillment of the project goals. So first, development computer vision algorithm to detect and track 3D objects on the road in the real time. Second, investigate and develop data fusion algorithms integrating pigeon data with the data from other sources. Third, develop methodology for road traffic system modeling. Lastly, the develop and evaluate novel comprehensive system for traffic data collection, analysis, and management application of artificial intelligence. Artificial intelligence in traffic system modeling. Large amount of traffic data is already available from various sources, including the traffic authorities and the RTT company on database. Big noisy data has to be processed in order to get a better insight into the system state behavior of transport users. So to define this big data, the basic definition is the through 3V as following: the volume, velocity, and variety. Multi-sensors, weather, environment, traffic monitoring, Internet of Things, sensors, and GPS are all data equations at the AQ sources. Comprehensive system for traffic data collection, analysis, and management. So our main objective is to develop ITS prototype to observe and control route traffic in the real time based on computer vision and other sensory data fusion. This is not done comprehensively, although the current data equation systems, hardware, communications, resources can support that approach. Moving to the high level concept of RTT. So as you can see in the left hand this is the whole process from the input to output with the processing engine. So the all sensors and all detected like Wi-Fi, Bluetooth devices, etc., CCTV devices, radar, third-party data, applications, all of them going to the big data, going to the system. So the device control the platform IoT, end-to-end integration, relight the configure and work all this to go the outputs web-based dashboard that you can see in your phone, tablet, laptops, as well as some notifications that you got in emails, SMS, social media alerts, and the third-party application that you can download it anywhere, roadside information, devices. The high-level block diagram of the RTT concept of cutting the edge of ITS system at the core of RTT proposed solution to write the platform. It is a unique digital solution, enabling the system integration and real-time data analysis. So, when we talk about the public in the transport system, so drivers and pedestrians, for example, all of us, the general public, are the key users and stakeholders in the transport system. We conduct research in the public behaviors in the transport and public opinion about the changes and the roadmap to the future mobility. Social media role in intelligent transport system. Nearly 2/3 of the Australian population own smartphones and use social media. Australian smartphone ownership rate is higher than most other developed nations. It is very important to leverage the cutting-edge technologies towards managing transport system. So, talking about the results in our public opinion survey on autonomous vehicles and discussions, parallel with the research in autonomous vehicles, engineering and technology in the development of a new algorithms for path planning. We conduct investigation in public readiness to accept the new technology. This is a large project that involves Australian, Saudi Arabia, and global community. While Australian and global survey are underway, key findings of Saudi Arabian survey are presented here. We had more than 199 participants, which include male and female drivers, and all of age up to 55 years age. We also included drivers and pedestrians with all educational level and management role in the industry and government. Benefits, as we can see here in your left hand, this is the results from the survey, and that was a correlation between the benefits and the age group. As you can see here, most of the response was taken from the age 26 to 35, and they were the highest benefits of the new technology in the age group of 26. So most of them, they accepted or they want to see this future autonomous vehicles. That could be expected as they are most likely in the growing path of their careers and are probably looking forward for the new benefits to be brought by the new invention. Going to see benefits, as we can see in left hand, by the different educational level. We can see that the participants with the highest educational level have the highest expectations of the new technology, but the correlation between levels of education and the expectation cannot be established. This might be the problem with the lack of knowledge about the new technology and what it brings. And here the benefits, as we can see by the key stakeholders. And the key stakeholders was the industries, government, traffic authorities, and public general. As we can see in the table, this is showing the highest response was from the traffic authorities by 44.4%, needing the autonomous vehicle to be exist. So benefits, as we can see here, by the management role. So the next two highest level of management staff have the highest expectation, with 28.6%, following with the people with no management level, as should be the majority of the public. To sum up, we have presented here our research in intelligent transport system, the ITS, development and new technology introduction to the public. Moving to the mobility of the future includes the state of art of ICT technologies, starting with the artificial intelligence, big data collected through internet of things, and computer vision, social media, and other sources. Cloud and edge computing are responsible for data processing in the real time. I would like to acknowledge the support of the Saudi Arabian government for sending me here to complete my PhD program under the Holy Mosques Scholarships Program, King Salman. And also would like to thank the former General Traffic Authority Sector in Saudi Arabia, Mr. Aid Al-Dakhilallah, for the help to support completing the survey during the difficult time of the pandemic in COVID-19. And thank you very much for listening. And any questions?
Thank you, Abdulaziz. Any questions, short question from the audience? I hope you enjoyed and listen to Abdulaziz, because we are doing survey in Australia and then we proceed with the global survey. So we encourage all of you to respond to Abdulaziz's request to do the survey globally. Okay, we are still short on time, but thanks for the great presentations. We go to next one, which is submission 115, how Thai microenterprises give significance to energy, the sustainable indicators. So the energy is extremely important. We are looking forward for this presentation by Dr. Jutamat Jintana.
Mr. Chair, sorry, my name is Sakasem Ramingbong. I'm one of the author of the papers. The presenter is, sorry?
You are co-author of the paper.
Yes. The presenter is actually on the travel. So I sent you the link of the video pre-recorded on the YouTube.
No, you can run the link and share the screen.
Okay. So I just share the screen on the
and before sharing, you click on the enable video. Audio.
One moment.
Good morning, everyone. Today, my name is Warataya Jang Prajang. I would like to present.
So, okay, we can hear you all good.
Sorry? Oh, good. Okay.
Micro enterprises give significance to energy in the case of the sustainability indicators. So actually, Thailand is an emerging and industrialized country that is located in Southeast Asia. And if you think about the GDP, Thailand is the top 25 largest economy in the world. And also the World Bank actually recognized Thailand as one of the great development success story due to a smart policy. Okay, it has become an upper middle income economy and is making a progress toward meeting the sustainable development goal, which is the SDG. So Thailand, SDG is Thailand actually ranked the first for the Global Sustainability Index achievement in 2021, and we are we are ranked 43rd out of 165 countries, and the SDG index score is 74.2. So what is the micro enterprise is very important. Now we will focus on the definition of the micro enterprise. The source are from the Office of SME Promotion that micro enterprise, both manufacturing, service and merchandising. The employment must be less than 5 persons, and also the annual income must be less than 1.8 million baht. The micro enterprises, if you're thinking about the number of enterprises, we are actually 85% of the enterprises in Thailand. And those 85% are actually
everybody, please
hire only 30% of the labor. And if we look into the value of the GDP of the micro enterprise, we give only 2% of the GDP in Thailand. And the things are, Thailand are similar to the rest of the world, that we are facing energy and environmental scarcity. Okay, we use like 2.07 million barrels of oil per day, but we can produce only equivalent of like 0.88. So in 2021, we are actually targeting.
Sorry for the interrupt. Everybody, please mute the mic. Please mute the mic.
Energy consumption to 25%. But till now, you know, as you can see that there is no official report investigating all the energy availability of the Thai micro enterprises. With such a number of the micro enterprises, the impact can be very high. So, and another way is the sustainability. In this slide, you can see that there is a lot of the work. The first one, Complete 2030 is like a bottom line, triple bottom line that the sustainable are actually the social environment and economics are putting together. And also the second one, we can call it NEST. Okay, the Shango is, we call it NEST, that sustainable is including in everything. And the third one, box sign, we call it 3 pillar, that the social, environment, economy are actually help their sustainability. So nonetheless, the core concentrations of the sustainability has 3 dimensions. The first one is economic, the second one is social, and the third one is environmental. So we're moving to the SDG, that is actually the Sustainable Development Goals that is doing by UN, that we have 17 of the category, 17 approaches, and those 17 approaches has about 232 indicators what data is available. Actually, the KPI are more than 232, but at the moment, what the data is available, we can track only 232 SDG indicators. And this one is the SDG that combined with the social enterprises in in every model, that we can see that we are all aligning together, that SDG and sustainability. So the objectives of this study is how Thai micro enterprises give significance to energy as a part of the sustainability indicators. And so the outcome, we actually want to know the perception of sustainability of Thai micro enterprise, that the government agency and the policymaker can make the industry insights and are suggestive if there can be any measure to leverage the energy, sustainability, or to any specific dimensions of this enterprise sector. So actually the methodology that we have 3 steps. Okay, we investigate 2 perspectives of the result. The first one, we development the questionnaire, and the second one, we do the data collection, and the third one, we are actually justification data and analytics. And the result, we have 2 things. The first one is we investigation the average score of the significant level of the sustainability indicators. And the second one, we're trying to find the correlation of the sustainability sub-dimensions. Okay, so step 1, we actually use Santi Tirakun framework to develop the questionnaire, and each of dimensions comprises 2 sub-dimensions, and there are 23 indicators. If we're looking a little bit closer into the indicator, we can see that energy that include in environmental, we have efficiency using the reducing energy consumption, we have substitution, renewable energy, we have shift to less energy products and technologies. So, and the second one, we do the data collection. We actually distribute like 100 micro enterprises in northern Thailand industry supply chain, and 49 questionnaires were returned. The survey are conducted during the period of January to April 2021. And the scale of 1 to 5 is being used. 1 indicates that at least important or least concerned, and 5 indicates the most significant or the most concerned. So this is an example of the questionnaire. So we come to the step 3, that the data justification and analysis, that as you can see, number 2 people and number 5 people, the average are different. Number 2 average is 3.5. So if they answer 2.2 to 4, that means it's very good for them. But for number 5, average for them is, for example, for 4.5. And if they answer 2.2 to number 4, that means this indicator is very bad for them. As you can see, so when we reduce the bias and subjective judgment for each respondent, so we use the simple linear normalization. And after that, the result and discussion, the first result is when we investigate the average score. Number 0 is the average score. So we can see that that is one part, okay, those parts are giving positively and some parts are giving negatively. And you can see the big part of energy, those 3 things are negatively concerned in the for the micro enterprises. So the investigation shows that the 5 most significant is standard wage payment, quality, efficient usage, and environmental emission reduction, reduction hazardous or the working time. But the top 5 least significant, we go with flexibility, operation cost, and substitution of renewable energy, labor costs, and also the shift to the less energy products and technologies. So we can say that energy is very disinterested by Thai micro enterprise. Okay, and then if we use a triangular distribution key by the RIG software, it shows that energy, okay, is the most minus on the mean. So this means that when it is very bad for the micro enterprise. And if we get into the correlation of the sustainability sub-dimensions, and we can say that there's positive correlation between energy, raw material, and natural resource. And some other way, we also have the positive correlation between energy and human resource management, and the indirect, okay, indirect correlation, okay, between energy, financial, and non-financial and ethics. Okay, so if we put in financial more, then the concern of the energy will become less. So the conclusion, this paper actually aims to report the perception of the sustainability of Thai micro enterprise according to the survey, how they give significance to any of these sustainability indicators. So the results show that the energy is one of the least concerning area of the Thai micro enterprises. Okay, so the substitution of renewable energy and shift to the less energy products and technology are amongst the least significant topics out of the 23 sustainability indicators. So that's why energy, and also energy has a direct correlation with a raw material and natural resource and the human resource management. Okay, so nevertheless, this paper, the analysis is statistically inconclusive as the sample are very small, but yet the result may be suggestive, and if policymakers wish to leverage the sustainability or to any specific dimension of these sectors. Thank you very much.
Okay, thank you, authors, for the presentation. Any short, quick question for Zach Gassem? You will be answering questions.
Sure.
Because energy is extremely important worldwide right now. That's why we have this conference as well.
That's correct.
Okay. I see Dr. Firoz, Professor Firoz is talking to somebody, but he is mute, so I hope he is not talking to us. Professor Firoz, you are mute. If you are talking to us, I don't know.
No, he's presenting a paper in another link.
Yeah, okay. I think he has two computers running. I have 3 monitors. Anyway, let's go to next one, which is me again. Thank you all for the presentation. Next one is submission 131, waste to energy by incineration of a pharmaceutical industry case study. Mr. Saad Mahmoud Soni. That one I have to run from the YouTube, and I am prepared to do that. Just 1 second. I'm going to share my screen. Let's see how this is going. Shared with the sound, yes. And maximize and
Chair, co-chair, organizers, and participants. Hello,
everybody can hear.
My name is Saad Mahmoud Soni, and I have a bachelor's degree in electrical and electronics, as well as a master's degree in RET, Renewable Energy Technology, from the University of Dhaka, Bangladesh. I've been working as a plant and project engineer for the past 7 years, so I'm primarily responsible for the utility sector, plant maintenance, and project management. On behalf of SQ
Milan, Dr. Milan, I think the video is not visible. Can you just make screen bigger?
It is the biggest from my side, but the presenter didn't make it bigger. I cannot control that part. You see, it is biggest from my side, but this on the left-hand side, this is what is recorded. Okay.
Live, I'm going to talk about waste to energy.
Sorry, because we can see author on the top, the left-hand side. So I'm not controlling. He didn't put in the presentation mode, but it's okay, I guess. Okay. Can I continue?
For the pharmaceuticals industry for the next 10 minutes. This work is based on my experience in working in the pharmaceutical sector. Background of our work. Why incineration is important in pharmaceuticals industry. Before talking about this importance of incineration, let me give you a brief idea of the incineration process. Incineration is a waste treatment process that involves the combustion of substance contained in waste materials. Incineration is a waste treatment system that is described as thermal treatment. Incineration converts the waste into ash, flue gas, and heat. Incineration reduces solid mass of original waste by 80 to 85% and volume by 95 to 96%. While incineration does not completely replace landfilling, it significantly reduces the necessary volume for disposal. Incineration has particularly strong benefits for the treatment of certain waste types, such as clinical waste and certain hazardous waste, while pathogens and toxins can be destroyed only in high temperature. Thereby, incineration is a mandatory requirement for pharmaceutical industry and healthcare facilities. Thereby, and due to all outdated and expired damage, QC failure, or unwanted control drugs should be destroyed to prevent the possibility of any unwanted medication or drugs to be shipped out from a pharmaceutical industry. We need to do incineration, and as the pharmaceutical waste is quite hazardous, due to significant health, environment, and biological safety issues, it is as it is far different from the regular waste, and therefore special measures are required to dispose it properly. Thereby, we use the incineration process. Let us come to our third slide, where we are talking about typical incinerators that we use in the pharmaceutical industry. Let me give you a brief discussion on this. From here, we are feeding the waste into our primary chamber. Primary chamber is the chamber where we all the waste will be loaded and incinerated for the first time. Volatilization of waste is primarily achieved in the primary chamber through a burner and to controlled air. The ash will be that after conversion of waste into the ash, the residue will be retrieved from here, and the volatile gas and moisture that will be coming out from the primary chamber will be then go to the secondary chamber. In the secondary chamber, we keep it in higher temperature than the primary chamber. It usually stays between 1050 to 150 to 1050 to 1150 degrees Celsius, and the result of that will be coming out from the secondary chamber is flue gas, and excess air are utilized in the secondary chamber. In the secondary chamber, accessories to the volatile gases in the primary chamber to complete the combustion process. Some of the gaseous products are completely oxidized in the secondary chamber due to sufficient residence time, high temperature, and 100% excess air. After the gas leaves the secondary chamber, they are treated. The gases finally enter the droplet.
Dr. Milan, your screen, we cannot see the screen, like the YouTube screen. Just maximize that one.
Sorry, you cannot see presenter screen.
No.
Let me just check that. No, we're gonna stop sharing. See what happens. Okay. Okay. Then sharing. This is the one. Can you see the screen now?
Yes, I can see right now. Yes. Yeah. Play from this place. Yeah.
Yeah. I will play from there. Yeah.
Gas temperature making it safe.
And sorry. For any problems with this, it is all on YouTube. So please, we continue where we were listening, but it's only a couple of slides, only first slide now. So you didn't miss picture too much. So keep going.
We let out in the atmosphere. Let's go to our next slide. Here we are discussing about our main objectives. Our main objective is to propose a model to categorize the different type of waste produced in the pharmaceutical industries and to estimate the amount of waste produced in the pharmaceutical industry from that model. Here we have categorized the waste that we will be we may be having in the pharmaceuticals industry. The categorization is based on their type, their characteristics, and we have given some examples. And here we have talked about their state, and their calorific value is given in this column. Next, we'll be going to our next slide. This is our case study, and we have further talked about the waste. This categorization is based on the waste that will be coming out of different manufacturing process and different activities from pharmaceutical industry. Here we have talked about the state of the waste, and this column represents the waste of the waste in weight, and this column represents the waste of the waste weight of the waste in per month. Our next slide is about the calorific value. We have provided the calorific value of solid medical waste here, liquid medical waste here, and this is the calorific value of diesel fuel. And this column represents the value of all this the waste type and the diesel fuel, and this is the ratio of the mixture. And we have used the calculation. We have done a calculation to find out the calorific value of the mixture, and it was found as 5,427.542 degrees centigrade. Our next slide talk about the workflow of our proposed model. From here we are feeding the waste in the bottom chamber. This is the representation of the dual chamber incinerator. This is the upper chamber. The flue gas will be coming out from the upper chamber, and this is the incinerator exhaust. The temperature from thermal energy from these two chambers will be utilized to generate the steam here. And we will be going to our next slide. This is about our schematic representation of our proposed model. Here we have provided the schematics that we will be using to convert our waste, the thermal energy from our waste to generate the steam. Here we are feeding the waste. Here will be here the control air will be entering into the primary chamber. From here we will be burning the waste from this burner. The temperature of the primary chamber will be stays within 750 degrees centigrade to 850 centigrade. This configuration represents the water tube configuration. This configuration will be utilized to generate the steam, and from here the volatile gas and mixed moisture will be going to the secondary chamber. The secondary chamber also has some tube-like structure like the primary chamber is having. This will also be utilized to generate the steam, and finally the pool gas will be discharged to the environment from this chimney type structure. And now we'll be going to our next slide. Our next slide is the representation of the energy output that we'll be getting when we are incinerating the waste. Here we have utilized the data from the steam table to have the steam exact steam pressure in the adjacent temperature, and this is the enthalpy of the saturated steam. This is the enthalpy of feed water, and we have considered the efficiency to be 70%. And when we utilize all this data, we are getting the capacity of our boiler that will be generating the steam while the incineration process is carrying out. The capacity was found as 1689.94 kg approximately. This slide is actually a brief summary of the results that we found after doing all this calculation. Here we have represented the steam related data. These are the parameters. This represents the temperature. This is the pressure representation. We have considered the efficiency as 70%, and the generation capacity was found at 1689.9. This was the capacity per watt. This is the representation of this column represents the fuel save. This is the representation of daily savings in kilogram. This is the representation of monthly saving in kilogram. This is the representation of yearly saving in kilogram. This is the carbon dioxide reduction in kilogram. This carbon dioxide reduction is done on comparing this the steam generation process with a typical diesel operating boiler. The boiler uses diesel to generate the steam, and we are using the diesel and the waste combination to generate the steam. So after our capacity was calculated from the capacity of our steam generation, the steam generation capacity of incineration was calculated. We have also utilized our model to calculate the steam generation capacity of a diesel boiler. Then we have used all this data to find out this carbon dioxide reduction. This is the money savings in US dollar. This represents the daily savings. This is the monthly saving. This is the yearly saving, and this is the landfill reduction in kilogram. So all this all this is a brief representation of the calculation that we have done throughout our work. So in conclusion, I would like to say that the proposed model and the case study analysis shows that the waste to energy has enough potential to cover a significant portion of the total energy requirement of a pharmaceuticals industry. So we have reached to the end of our presentation. As our presentation is about to conclude, I will once again like to thank you for giving us the opportunity, and hope that this activity has given you a much clearer understanding of waste to energy production through the incineration process for the pharmaceutical system. Thank you. Thank you for giving the opportunity once again. Take care.
Okay. Thank you, presenters. Do we have any authors or authors? Yeah.
Okay, can I have one question? have you considered the environmental impact of this work? Sorry, can you hear me?
Dr. Biral, I think the presenter is not present here.
Yeah, I don't know. I think that big boss, Professor Firozi, is somehow interfering to our session.
Yeah, we can go for the next presenter.
Okay.
Yes, we can go. I don't know. There are too many bosses, but anyway, it's next session 132, energy efficiency improvement of vertical hydraulic systems. Mr. MD Masood Rana, Upscube Engineering Education Services, Pty Ltd, Australia.
So good morning. Is my slide is visible and my voice is clear?
Yes.
Honorable Chair, Co-Chair, and the participant, good morning. My name is Masood Rana, graduated in mechanical engineering, and I did masters in the same area from RMIT University. Last 10 years, I've been developing servo positioning machines and pair parts for manufacturing industry. I am presenting this paper on behalf of Upscube Engineering and Education Australia. Next 10 minutes, I will be talking about reduction of energy consumption of a vertical cylinder servo hydraulic system. As you might know, hydraulic systems have unfavorable energy efficiency factor compared to other technology. Generally, hydraulic-driven equipment consume more power than electric-driven or motor-driven system. But we cannot use motor-driven equipment for heavy loading because of the limited load-bearing capacity and, of course, high cost. Therefore, unfavorable hydraulic-driven system become obvious for our industry, especially construction, mining, and manufacturing. My research focus mainly on vertical and inclined hydraulic cylinder operated machines to lift a heavy load. For example, hydraulic forklift, hydraulic lifter, hydraulic CNC hydraulic press, hydraulic lift, etc. My research background was like, as you might know, when a vertical cylinder is operated against a gravitational force, during this lifting, it requires to supply energy to overcome the lifting force. However, we can use this potential energy to down the load by controlling the flow of the fluid. But it requires flow control and directional control valve. Downstream fluid velocity depends on the load of the system. To calculate the energy, flow control valve and directional control valve are throttle valve that has a significant loss of energy. The greatest problem is by operating this throttle valve and hand lever valve, it is not possible to control the accurate positioning of the cylinder at a required position, which is very essential for computer numerical control machineries. Other than potential energy, there is another energy known as pressure energy, as the rod side pressure is more than the piston side pressure. To overcome both of the energy, to recover both of the energy, a closed loop servo hydraulic valve and a bypass valve is introduced in this system. My objective is to improve energy efficiency of a vertical hydraulic cylinder servo hydraulic system and investigate the energy efficiency at different load condition. In this slide, you can see in the left a conventional servo hydraulic system to position accurately with a load on it. And the right, the same system with a bypass directional control valve is operated by the PLC program, and it's open when the load goes down only. The bypass valve is completely closed when the cylinder goes off. So this is my, this slide you can see the hydraulic fluid flow and electrical signal flow diagram. Hydraulic servo valve is controlled by a 0 to 10 volt signal generated from Siemens S7 PL1200 PLC, and a feedback signal comes from a linear potentiometer. The bypass valve is operated by a signal comes from the PLC also. A function generator is used to generate a sinusoidal signal as a command signal. To calculate the energy, a lab view based data logger is used to record the pressure and flow of the system. So here you can see this is my actual setup. You can see here a Siemens PLC and a servo hydraulic valve, a cylinder with a 10 kg load, and pressure and flow sensor integrated with the cylinder, and a function generator to generate a command signal. And of course, there is a lab view software on the computer to record this all data. So this is my instrument I have used in my experiment. This one is easy port USB. This is it's made from Festo. And this one fluid lab hydraulic is a lab view based software that can record all data coming from this my experiment. And this is Siemens S7 1200 PLC. This one is used to control the all control process, I mean PID control loop for the system. So this one is a sample data I have taken, and this data is taken like 80 data per second. In this slide, you can see the recorded data for pressure and flow to be measured for power calculation. As you might see, with a bypass valve, the flow curve covers less area than without bypass valve. And this is the same curve, but 20 kg load. In this slide, you can see this experimental result, and for 10 kg and 20 kg load, and with a varying pressure. For example, at 20 kg load, 20 bar pressure at 10 kg load, efficiency is more than 60%. Sorry, 6%, and at 60 bar pressure and 10 kg load, the efficiency is 3.79%. And with 20 kg load, you can see here at pressure 45 bar, the efficiency is 17.25%, and at 60 bar is 10.78%. That means when the pressure is gradually increasing, the efficiency is also decreasing. But at the same time, when you increasing your load on the system, the efficiency is also increasing, but it's still gradually decreasing by increasing the pressure. So here is a curve that I have plotted here. The vertical axis is energy efficiency and the horizontal is pressure. Here, as you might see here, at 20 bar pressure and at, for example, 10 kg weight, the pressure is slightly increased and finally is decreased at 60 bar pressure. But you can see for 20 kg load, the efficiency is higher, but it's sharply decreasing. So in conclusion, I can say a vertical cylinder servo hydraulic system with a bypass valve, which only open during the cylinder is downside, it gives the higher energy efficiency than without bypass valve. The energy efficiency is higher at low pressure, and it gradually decreases when the operating pressure is going high. When the cylinder load is doubled, the efficiency also increases. Maximum energy efficiency can be achieved by keeping the pressure as much as low to maintain the required velocity and by putting the maximum load on it. So thank you very much for your kind attention.
Okay, thank you for the presentation. Any quick question? So we have another presentation now from the same institution. It is submission 120. Numerical investigation of copper fin influence in phase change material, PCM, cooled hybrid electric vehicles engine. So Mr. Hanjay Ram, I guess you are here. Yes, we are welcome.
Yes,
to share your
yeah,
screen.
good afternoon to everyone. Good afternoon, everyone. Am I audible? Am I audible to everyone?
Yeah, yes. It's your turn now. You can share your screen and we are all listening.
Sure. Thank you so much. Respectful good morning and good afternoon to everyone. So I'll just share my screen now. Yes. So I'm here to present the topic numerical investigation of copper fin influence.
You can just put it in presentation mode.
Yeah, sure.
If I go to that seasonal variation on the left side, you may see on an average it produces about 4,000 kilowatt hours.
Sorry, before that, please everyone mute your mics. Everybody, please. I see a couple of people. Please, everyone, mute your mics. Okay, a lot of mics running here.
Every half hour, average generation, every half hour on the day. So it's about 2 hours.
Professor Firoz and Asad, can you mute your mics, please?
Yeah, I think it's clear now.
It's okay.
So,
okay, all yours. You take the control.
Okay, thank you. And good afternoon. And I'm here to present my topic, numerical investigation of copper fin influence in a phase change material cooled hybrid electric vehicle engine. And I'm presenting this on behalf of ASEP Engineering Education. And my name is Sanjay Subramanian Ramnathan, and I'm a project engineer for ASEP Engineering and Education. So without wasting any more time, I'll quickly move on. So first of all, so what is the main objective of this topic? The main objective of this research is to determine the influence of the copper fin in a phase change material cooled hybrid electric vehicle engine. So we have seen a massive intervention of electric vehicles in today's world. Like we also feel that this is the way forward. And when it comes to thermal management systems, it has always been a concern. Like there has been some thermal runaway propagations in the past. There has been some accidents, some fire accidents and so on due to overheating of the engines. So the goal is to determine a proper cooling methodology. So that is why the research we have done here. And there is an inevitability of the automotive industry moving from the conventional gasoline engines to the hybrid vehicles. And based on that, there are different cooling methodologies like the active cooling and the passive cooling. So the active cooling involves the liquid cooling or the air-cooled engines, air-cooled hybrid electric vehicle batteries. Whereas the passive cooling is something where you use fins and phase change materials to store, high latent heat so that it can absorb the heat away from the battery, and then it can deposit on the phase change materials. And we can very evidently see the cost advantages, and it also becomes simpler when you have a PCM. There's not much of ducts that you have to use in order to design a passive cooling methodology engine. So moving on, what is the methodology that we have used here? So we have gone for two geometrical models. So one model with the no fin and the other model with the 8 fin. So this 8 fin model consists of each fin being 30 mm long and 1.5 mm thick. And the diameter is around 150 mm. And this is our computational model. And the no fin material consists of nothing but the PCM and a copper ring, as you can clearly see. So we have done a 2D analysis. And basically, the edges of the fins are filleted, as you can see here. So regarding the mesh, so we have again the no fin model and the fin model. We have used quadrilateral meshing for both the cases, and the orthogonal quality was very much in the acceptable range, around 0.98, and the skewness was less than 0.3 for both the cases. So we should be expecting very accurate results. Next, the boundary conditions. So the flow condition, as there is not much flow here, it's only the flow due to the natural convection. and due to the buoyancy effects. So we have used the flow condition as laminar, and we have kept the solidification melting condition and also the energy. And the analysis type, we have gone for a transient analysis because it will give us more of an idea of what is exactly going on with respect to time rather than a steady state. And the solid that we have gone for is copper. The reason that we have gone for is copper, because previous analysis they have used aluminum fins, but we have used copper. The main reason for using copper is that it has a higher thermal conductivity. So once you wrap the copper around the battery, so it can pump the heat away from the battery much more quicker. And that is why we have gone for copper. And the phase change material that we have used is a commercially available phase change material, which is the Rubithum 58. So the Rubithum 58, the reason for choosing Rubithum 58 is there are a variety of reasons. We found a lot of advantages for Rubithum 58. So the main advantages, as you can see in the slide, that melting heat is around 180 joules per kilogram, which means it requires a lot of energy for it to melt, so that it can take more energy, and then it can use up more energy from the battery, and the melting time can be longer, which is what we require. The latent heat, we want to be able to store a high amount of latent heat. So the solidus temperature and liquidus temperatures are have a difference of about 14 Kelvin. So which means that we will see a little bit of a slant in the curve during the latent phases, not a straight curve. Now moving on to the results. So as you can see on the top, it's the no fin case, and on the bottom it's the 8 fin case. So you can see that the buoyancy effect can be seen taking place around the 22-hour mark. And I should mention that the gravity is in the minus y direction. So if you see this as a 2D plane, as the XY plane, so the gravity we have used in the minus y direction. And you can see that in the 22 hours mark, there is a buoyancy effect that starts to take place. Natural convection starts to take effect. And from that point, the natural convection starts, and then the melting starts as well. So it starts to melt, and that temperature is around like 48. But then if you take average, it starts around like 50 degrees Celsius, which is about 323 Kelvin. Now moving on to the temperature plot. So you can see that the 8 fin model melts much slower than the finless model, that is a no fin model. And the melting begins earlier for the finless model and finishes earlier when compared to the 8 fin case. The delay in melting can be attributed to the extra thermal buffer, which is the copper fin. And the reason that we are saying that is like the copper fin acts as delays the heat getting into the PCM, and that is a very important thing in the long picture. And the slant line in the latent heat phase can be attributed to the difference in the solidus and liquidus temperatures of the RT58, and that can be an advantage as well. Moving on to the liquid fraction. If you can see here, the liquid fraction is like, for example, the 8 fin case and the no fin case are very much distinguished. So if you see the final, it is 1. The liquid fraction is 1, which means it's completely liquid. It starts off at 0, which is completely solid. And the liquid fraction for the no fin case completes at about 221,000 seconds. And for the 8 fin case, it completes about 210,000 seconds. Moving on to the float. So the melting phase begins at about 35,000 seconds for the 8 fin case. That is the fin case, it starts later than the finless case, which is about 25,000 seconds. And the delay in melting is due to the copper fins, which pumps the heat away from the battery, acts as the extra thermal buffer, and then it moves on to the PCM. That is the extra 10,000 seconds. The reason for the extra 10,000 seconds is the copper fin. And we can also quite clearly see that there are the slopes of both the finless case and the 8 fin case are almost parallel, which means the rate of melting is quite similar. But as you can see, it is slightly steeper for the finless case, but for the 8 fin case, it is slightly, it's not that steep, but it's almost similar. So the rate of melting is almost similar. And if you see the temperature plot here, we can see a much more uniform temperature in the 8 fin case. And in the no fin case, the temperature gradient is much more higher. Like, for example, the maximum temperature attained is around 76 degrees Celsius. And for the 8 fin case, it's about 62 degrees Celsius. That's the maximum temperature attained. So moving forward, fins play a major role in delaying the melting process by acting as an extra thermal buffer that we have already discussed. So the major findings that we derive from this research is what is the influence of the fin? So the first thing is the copper fins help remove the heat from the battery at a much faster pace than that of the copper ring without any fin. And the 8-fin case provides a more uniform temperature distribution. As we saw, like the maximum temperature was 62 and the minimum temperature was around 58 and the average was about 60 degrees Celsius. So the average temperature at the time of completion of melting of the no-fin case is 6.75 Kelvin higher than the fin case. So that is another conclusion that we have made from this research. And what can the future simulations, what future simulations can be made? So it can be based on different cooling methodologies and different types of materials used in the cooling methodologies. And we can go for a hybrid cooling methodology like the active passive cooling methodology rather than active and passive. And it can be seen if it gives better results and if it gives better battery operating conditions. And the number of fins can be varied because here we have used two models. One is a finless model and the other one is 8-fin model. We can actually try to see more fins, like for example 16-fin model or a 4-fin model, to see how they affect the overall working condition. So we have come to the end of the presentation. I would like to thank my co-authors and acknowledge them for their help and support during this research. And thank you so much. And if you have any questions, you can please let me know.
Thank you, Sanjay, for the interesting presentation. Just a quick one. You said future simulation. Are you planning to do field testing as well?
Yeah, that is one of the goals. We are trying for some field testing as well, but in the future. Yeah.
Okay. Any other quick question? Okay, we are good on timing, relatively okay. We have 18 minutes for the keynote, keynote number 9, role of hydrogen in achieving net zero emission. Professor Mahmoud Hossein, Robert Gordon, University, United Kingdom.
Thank you so much.
Yeah, thank you.
Hello, good morning. Can you hear me?
Yes, yes, you can just make a presentation mode and all yours.
Give a second. It's on the, yes.
All good. Okay, I will hide and you have all control. Good luck.
Thank you, Professor Milan Simic. My name is Mahmoud Hossein. I am from School of Engineering at Robert Gordon University in Scotland. In this presentation, I'm going to talk about little bit about hydrogen and the research we are doing on hydrogen at Robert Gordon University. Before that, let me acknowledge the contribution of my colleague, Dr. Nadibul Faisal, who also contributed to this presentation. Now, if I think about Robert Gordon University, which is at the end of Scotland, near North Sea. And traditionally, Robert Gordon University is actually known as oil and gas university. So our initial research for the last, I can say 25 years, 30 years is on oil and gas. But as you know, throughout the world, we are not moving towards energy transition, trying to achieve net zero emission. So our research at the university is also moving towards energy transition and trying to achieve net zero and how we can contribute to that agenda. So we are going to talk about hydrogen and the role of hydrogen in achieving net zero emission. So if you look at Committee on Climate Change in the UK, they have recommended that if you want to come out of the post-COVID situation for economic growth, UK should invest heavily on climate change to create economy and to create new jobs when we come out of the COVID-19 situation. If you look at some of the forecast, UK Hydrogen Task Force, they are saying that there will be 75,000 jobs by 2030 in the UK. Similarly, another prediction is that we'll create 200,000 jobs by 2050 in hydrogen economy. If you compare that with oil and gas job, currently the oil and gas industry support 260,000 jobs across the UK. So by 2050, if we believe in Equinor report, we may achieve similar job prospect in hydrogen economy. And finally, if you look at they come up with a hydrogen plan, how to we move on to hydrogen economy. And what UK government plan is to use hydrogen by 2030 to heat people's home, businesses, powering cars, cookers, boilers, and more. So basically, we are moving on to hydrogen into transport, into heating, into cooking, and things like that. In order to achieve that, of course, we have to develop the technology rapidly. If you look at this map of United Kingdom, it's actually made of 4 countries, England, Wales, and Northern Ireland. These 3 countries are quite intimately linked. However, which is in the northern part, they have their own parliament and you can say some kind of autonomy. So Scottish government is also interested in hydrogen economy, and their forecast is that by 2030, 5 gigawatt of low carbon hydrogen will be produced in Scotland. And this is the part of Scotland. We are Robert Gordon University, or Aberdeen is somewhere here, North Sea, and this area is full of offshore oil and gas platform. So moving on, they are currently, this map shows current hydrogen project within the UK, and you can see this is Aberdeen. There is a project here running on hydrogen. I will explain that in a minute. Then some project near Edinburgh, Scotland, and most of the hydrogen related project is down south. This project is basically either hydrogen pumping or production of green hydrogen kind of thing. And in future, there will be a lot of electrolyte hydrogen production planned around this Scottish region here, mainly offshore hydrogen. So if you look at these areas, these are offshore oil and gas platforms. These will be converted into offshore wind and then green hydrogen production and things like that. In terms of hydrogen transport, and if you look at hydrogen filling station, currently in UK, we have only about 11 hydrogen filling station, and these are kind of a demonstration project. Okay, it's really commercial because we don't have much hydrogen car running around. We have more electrical car than hydrogen car. But if you look at this, out of 11, 2 hydrogen pumping station is actually within Aberdeen city. So Aberdeen city, where our university is massively interested in hydrogen technology and trying to make Aberdeen as a hydrogen hub inside the UK. If you compare this 11 hydrogen pumping station against currently available petrol station, will have 8,380 operational petrol station across UK. So you can see the massive difference in the availability of hydrogen across the country. Okay, moving on to the next one. As I said, hydrogen economy has been considered in Aberdeen city because, as I said before, it is known as a oil and gas city, but they are trying to move on from oil and gas to hydrogen. So a massive hydrogen project is going on around Aberdeen city. So I'm going to talk about a little bit about hydrogen hub, Acon hydrogen, and energy transition zone that is across Aberdeen. So if you look at this map here, project is preliminary focused on generating the blue hydrogen. So we have all sorts of hydrogen, all sorts of gas is produced in North Sea. These are also landed at St. Fergus around here. And the idea is to convert that gas with to hydrogen, and then while subsequently produces carbon dioxide is captured and stored back into depleted gas reservoir. Okay, so this St. Fergus is actually a very good location where you have the existing infrastructure of oil and gas pipeline. So we can still oil and gas is coming to St. Fergus. If you have a steam reformation to hydrogen production, carbon dioxide will be released and that will be captured here. Then through this existing pipeline, we can blend hydrogen into the existing pipeline and then transport all over the UK. So infrastructure of pipeline is there, infrastructure of gas terminal is there. So there is future in producing hydrogen. And this project will start very soon, within 3 years. Another massive project going on in Aberdeen is hydrogen bus. It started off with 2 hydrogen bus. Now we have 65 hydrogen bus running across Aberdeen. We have 2 hydrogen fueling stations, as I said before. Another project which is looking at converting offshore wind into hydrogen. Recently, this company Dolphin on this project, 3.12 million pound investment. They are putting it 10 megawatt kind of a demonstration unit. You have offshore wind connected to desalination plant and electrolyzer that will produce green hydrogen, and then will be transported through the offshore pipeline into the land. Okay, so what is the method of producing green hydrogen? The main method of producing green hydrogen is electrolysis. Currently, most of the hydrogen in UK is produced from steam reformation of natural gas. However, if you look at the capacity of electrolysis, you can see it's rapidly increasing. So in future, hydrogen will be produced in a green source. That means splitting water using renewable energy source in an electrolyzer. Okay, so let's look at how the electrolyzer works. Electrolyzer is made of a polymer electrolyte membrane in the middle. Then you have cathode and anode section. Within that, you have a flow channel. If you look at the anode, through the flow channel, your water flows through that flow channel. Then it diffuses through this porous diffusion layer into the catalyst layer here. In this zone, due to electrochemical reaction, hydrogen is split into water. Water is split into hydrogen and oxygen. Hydrogen atom flows through polymer electrolyte membrane into cathode section. We need to put electricity to transfer free electron from the anode side to cathode side, and the cathode side, again, the electron and proton, that is hydrogen, combine and create hydrogen gas. While in the anode side, we have a water, and then you have an oxygen generated. You have to remove the oxygen through the water. If you design that properly, then you can convert more than 70 or 80% of water into hydrogen, and rest water and the oxygen gas remain inside the anode section. From the fluid dynamics point of view, you need to design this channel appropriately so that you can move water and oxygen quickly out of the channel. So I'm going to show a little bit of research work that we have done at RGU in terms of flow modeling and fuel cell modeling. So we started our research on fuel cell, and then we are slowly moving on to electrolyzer. In a fuel cell, which is inverse of the electrolyzer, again, we have a, this is the Ballard fuel cell. These are made of fuel cell stack. Each of the stack is made of, as I said, anode cathode section as well as polymer electrolyte membrane fuel cell, and then you have gas diffusion layer kind of thing. Okay, so and if you look at what happens inside the flow channel, you can look at in this figure, which is very similar to electrolyzer that I explained a little bit ago. So one of the challenges of fuel cell is that when electrochemical reaction happens, a lot of water is generated inside the fuel cell, and that blocks the channel. So if you look at gas diffusion layer, water is generated, this water then block the channel flow. Electrochemical reaction basically stop if you cannot move the water quickly. So we have done a numerical simulation to look at how water is generated inside the fuel cell and how we can move this generated water quickly. So we are looking at water dynamics. So we are basically looking at flow channel. Within the flow channel, a lot of water is generated, and you can see individual droplet coming out from gas diffusion layer. They are interacting with each other, creating a big slug body, and basically it stops the flow channel to new reactant coming in. So what we can do, we can move this water quickly by arranging those droplet by using laser cutting on the gas diffusion layer. So we intentionally cut bigger hole along the wall through which we allow water to come out, and we make this wall hydrophilic. So as soon as this water touches the wall, it will be spread as a thin film, and but that way we can keep this gas diffusion layer and the channel clear of water. By coming up with this innovative design, we managed to reduce the surface coverage of water by more than 50%, and amount of volume of water reduced little bit, but it doesn't matter how much volume of water is there. Main thing is that it is not blocking the surface of the gas diffusion layer, that is creating a film on the channel. Similarly, we have looked at performance of the fuel cell work inside, and we have seen a lot of water is actually accumulate under the land area. So we have to do something to remove water from this land area. And we have also investigated the performance of the fuel cell. If you look at the porosity of the gas diffusion layer, if you increase the porosity, performance increases at higher current density. We have looked at permeability of the gas diffusion layer, and as I said, if you increase the permeability of gas diffusion layer, its performance increases little bit. And similarly, we have looked at the ratio of the land versus the flow channel area, and we have seen if you have a smaller land area compared to flow channel area, then we can have gain some performance. So by managing every little parameter inside the fuel cell, we can increase the performance of the fuel cell. And final performance improvement comes from pumping massive amount of oxygen. So if you think of stoichiometric reaction, which is 1, if you pump 7 times the stoichiometric oxygen, you can improve the performance significantly. Of course, there will be parasitic locks because you are now having a bigger compressor to pump oxygen at a higher pressure. So as I said, those are the fuel cell research that we have done. Now we are moving on to electrolysis research, which is inverse of the fuel cell, and we are trying to generate hydrogen. Is a massive. We have 11 staff now move on from oil and gas research into hydrogen research exclusively. We are looking at material, we are looking at flow dynamics, we are looking at integration of electrolyzer with the wind turbine. So we have a big group that just started research on this hydrogen production, and we are hoping to publish some of the results very soon. And we are open to collaboration. So anybody is interested to collaborate with us in this area, we'll be happy to explore different level of collaboration. Okay, so these are some of the funders that supported our research, which is Carnegie Trust for the University of Scotland and Northern Research Partnership. We have grateful to Simon Fraser University at Vancouver, Canada, for offering a visiting research position, and also our Robert Gordon University funded some of the research from their pump priming funding to Dr. Sheikh Islam and Dr. Nadimul Faisal. Thank you very much. This is our university, which is a new university, as I said. It used to be oil and gas university. As the world move on to energy transition, our university is also moving on to energy transition and moving on to research on hydrogen fuel, green hydrogen production. Thank you very much for your attention, and I will be happy to take any question.
Thank you for the great presentation. The timing is perfect. We have time for quick question, which will take 30 seconds. Okay, I would like to close this session, and now everybody, we can join closing session right now. I am not in control anymore. Thank you for attending and for presenting. Thank you, everyone, and thank you for the organizers.
Thank you, Milan. Thank you very much for your support. And we'll have a closing session, and other sessions are going on. So we'll wait for a few minutes. It's like a break. So we'll start according to our schedule. Okay. So just we'll have a small break, and after the break, we'll come back.
Dr. Milan, will you stay in this link for the closing session or move on to different link?
Sorry.